Hi, hi students. Today we will discuss about, in the previous session we discussed about the refraction of light. The refraction of the light, what is the refraction of light and its properties and how it changes. And simply refraction of the light is when light travels from one media to another media, its speed changes of that particular pair of media. So this is called refraction. So we come across with Snell's law and refractive index of the various materials. Now we discuss about refraction of the light by spherical lens. Refraction of light by spherical lens. So before going to the discussion, we'll find what are the spherical lens. What are the spherical lens? Spherical lens means if you take a sphere, it's a circle. When we take a ball, if you take a football, it's also in the two dimension. It looks like this only. So when you cut some piece of this one, so this is the radius, and the radius is same in all directions. Okay. If you cut this piece, it looks like this, right? If it is a solid sphere, if it is a hollow sphere, it looks like this, right? So spherical, simply we say spherical lens is, there are two kinds of spherical lens. One is convex lens, another one is concave lens. What is mean by the convex lens? Convex lens means if you hold the lens with your fingers, you can sense the middle part will be bulged. Thickness is very high at the center and edges are thin. Likewise, for concave lens, thickness is less at the center and at the edges thickness will be high. These are concave lens. Now we deal with double convex and double concave lens. Double convex and double concave lens. So double convex lens look like this. Double convex lens. It look like this. Similarly, double concave lens. It look like this. So what is the difference? The main difference is, for convex lens, center will be thick, and for the concave lens, center will be thin. Okay. So here we have another. Now in the previous session we talked about refraction of the light through various media and what are its properties and what is the refractive index of various materials. So all those things we have discussed in the previous session. Now we are not into that one. How these lines will behave when light passes through it. Now light will pass through it. How we defined refraction? Refraction of light means when light passes from the rarer medium to denser medium, its speed reduces. Similarly, when denser medium to rarer medium, its speed increases. This is what the refraction we have defined in the previous session. Now, a simple example for the convex lens and concave lens. We come in our daily life, we come across with a situation. If we in childhood, every person, if you hold a magnifying lens and you in the sunlight, if you focus those sunlight on a paper, it will burn, right? So what happens there? All the energy is concentrated at one point, and it causes for burning of the paper. So this is a kind of refraction. Okay. Now one by one we will go with. We have many cases with refraction. We have many cases with refraction of light through lens. In the previous session, we only discussed the light, how the light passes. That's only. But when it comes to the lens, we have a different cases. Okay, concave lens is like this, and when before going to that, we have a few points to remember. That is, the center of the lens is called. Center of the lens is called. This center is called center of the lens. The line passing through the center is called. This is called principal axis. Principal axis. And very starting we discussed radius from where this part is separated. So if we extend this one as a sphere, it gives a radius. This is called center of this is what we call radius of the lens. So radius of the lens, C. This is actually the radius of the sphere. And again, focus. What is the focus? In the magnifying glass, we have discussed one thing. When lens passes through this one lens and it will focus on a point, causes the burn. Likewise, when parallel lines, I will discuss in detail. When parallel lines passes through this lens, those lines will merge at some point. This is called focus. I think you are getting my point. This is called focus. In the same, if lines parallel line when parallel rays passing through this lens, they will focus at a point. This is center, this is focus. Those lines will converge at one point. This is called focus. As it is a double convex lens, we have two foci and two centers. That is two radii. We call this one as C1, this one as C2, this one as F1, this one as F2. For sake of convenience, this double convex lens, two sides have the radius are similar and the foci also are similar. So that in the next discussion will go easy. In the first case, when object is placed here, we have a convex lens. This is the principal axis which is passing through the center, and this is radius, this is focus. A simple case I am discussing this. If object is placed somewhere here, so these parallel lines are passing likewise. Okay. Where the image will be formed, when lines are coming from the infinite and parallel to the principal axis, they will converge at the focus. Okay. Here in this case, image formed is highly diminished and inverted. So this if the person is like this, if the image formed also like this, this is object, this is image. We call it as erect. If the image formed like this is called inverted. I think you are getting my point. So here in this case, image formed size is very diminished and the image formed is inverted. Okay, let us leave this case. Now again, we have a second case. Likewise, principal axis is similar. C is here, F is here. Object is just beyond C. In this case, where the image forms. So, remember, all the parallel lines will converge at focus and the lines passing through the center will not deviate it. So, and another line is passing through the center. Here we get the image. Here it is not highly diminished. Of course, it is not highly diminished. It is inverted. That means diminished and inverted. So now coming to another case. This is the second case. Now we take the third case. Image exactly at the radius. image exactly at the radius. Now in this case what happens? One parallel line will come like this. Oh, we can say this parallel. One parallel line comes, this one passes through the. Okay, now another line will pass through the center, forms the image here. Here in this third case, what happens? Image formed is of same size, not diminished, same size and inverted. In this case, when object is at the center, image formed will be at the center and it is inverted. Now coming to fourth case, we have a convex lens and see, this is F, not E, this is F, this F, this C. Okay. Image is in between C and F. In this case what happens? In this case, image, where the image forms, it forms beyond C, large and inverted. It forms, where it forms, it is formed beyond C, image formed beyond C. This is enlarged and inverted. We have one case remaining, that is, suppose image exactly at the F. Image exactly at the F. What happens? So in this case, image will be at the infinity. Image forms at infinity, enlarged, highly enlarged and inverted. What happens when the object is at F? Image forms at infinity. Now coming to sixth case, when we have the same scenario repeats. Here C, here F. Now image, object is in between F and C, F and O, center. This is object. Here we get a different kind of result. See, on the image formed on the same side, not on the other side. In this case, image forms on same side in between F and C, and it is not inverted. It is image is enlarged and erected, not inverted. on same side, not on the other side. Okay, this is refraction of light by the spherical lens. In the case of convex lens, we get all those results. Okay, we have another lens, another spherical lens. What is it? Concave lens. Now we'll discuss it. Concave lens. Here we have only two cases. Concave lens will be like this. All other things are same. Here only one thing is we don't get the image on the other side, on the same side only. When object is at infinity and lines parallel to the principal axis. So here in the previous, in the case of convex lens, all those parallel lines are converged at the focus. But here in this case, these parallel lines, lines which are parallel to the principal axis are diverged like this. That's why concave lenses are also called divergent lens. Convex lens are convergent lens and these are divergent lens. If you see these divergent rays, if you extend them, they will converge at some point on the principal axis on the same side. This is called F. Okay, now here we get the image. Image is highly diminished and real. Real, erected, highly diminished. Okay. So here image forms on same side, diminished and real. In the previous case, we get real images. All of them are real images. Here we get on the same side, but these are virtual images. Second case. Second case. When the object is somewhere else. When the object is somewhere else in between O and infinity, maybe at C or like this. So here we get so lines will be like this. Object forms on the same side. The case is the similar one. Okay. Object falls beyond C, somewhere else, here on the same side. This is virtual, not real, and direct. This is enlarged. Got it? On same side. Enlarged. Real. So these are the only two cases with the concave lens. With this we completed refraction of light by spherical lens. Again we have ray diagram, we covered ray diagram and image formation and other things, but we have mirrors. That is also we will discuss in the next class. Thank you.